Hello friends, I'm Mr. Pankaj Borah, Assistant Professor Juhat Institute of Science and Technology in the Department of Power Electronics and Instrumentation Engineering. Today, I'm going to discuss about the solar photovoltaic or PV technology. After seeing this video, you'll come to know the need of solar power, what is solar PV system, and solar PV cell characteristics. Now, let us know what is solar energy. Solar energy is the most readily available source of energy. It is free and it is also important of the non-conventional sources of energy because it does not pollute the nature. It is very high time to harness and utilize solar energy to reduce greenhouse gas emission. Most importantly, the energy supplied by the sun in 1 hour is almost equal to the amount of energy required by the human population in 1 year. The sun radiates two types of energy, as you can see from the figure. One is the heat energy, which is used for solar thermal applications. Secondly, light energy, which we can convert to electricity by using solar photovoltaic or PV cells. This is the topic of my discussion today. Now I'm going to explain what is solar photovoltaic technology. The photovoltaic technology starts from a solar cell. A solar cell converts light energy to electricity. The most common material used in solar PV cells are silicon. The silicon solar cell, which gives output voltage of 0.7 volt under open circuit condition. When many such solar cells connected in series, we get solar PV modules and likewise an array. As we can see in the figure, an array is designed as per the load requirements. When solar cells are connected in series, voltage will increase, and when cells are connected in parallel, current will increase. Normally, in a module there are 36 cells, which gives 23 volt. Different factors affect the solar cells. These are climatic conditions like humidity, radiation and temperature, spatial placement, that is to install solar PV system facing towards sun for better performance, and load. The solar PV system is designed for particular load requirements. The main components of solar PV system are solar PV module, which generates electricity in DC form, the charge or drive controller, which transfers maximum power to loads and charge batteries, the battery, which stores the charges at daytime. The first generation of solar cells are produced by crystalline structure of silicon, but presently different types of solar cells are produced by different manufacturers. These are monocrystalline, polycrystalline and amorphous. Now I'm going to discuss about the solar cell characteristics, which are short circuit current, open circuit voltage, peak power, fill factor and efficiency. The five factors that I have mentioned here gives the ratings of a solar module to design a power plant and performances. The short circuit current is obtained by short circuiting a solar cell or module. In the figure you can see the IV characteristic of solar cell. The voltage is shown in x-axis and current is shown in y-axis. The short circuit current is the current through the solar cell when voltage across the solar cell is 0. Here in this IV curve shown in the figure, the point marked as X is shown as short circuit current ISC, and at P equal to 0, the I equal to ISC, that is short circuit current. The short circuit current is due to the generation and collection of light generated carriers. It is the largest current which may be drawn from the solar cell. The open circuit voltage, termed as VOC, is the maximum voltage available from a solar cell, and definitely this occurs at zero current. In the IV curve, the open circuit voltage is pointed at Y. which is shown in figure here. This open circuit voltage corresponds to the amount of forward bias on the solar cell junction due to illumination. In the IV curve of a solar cell, it is shown that maximum power we can get from a solar cell at the knee of the curve. Here, in this figure of the IV curve, PM is the maximum power point. Mathematically, you can write maximum power point PM is equal to maximum current IM into maximum voltage VM. The field factor of a solar cell is the ratio of the maximum power from the actual solar cell to the maximum power from an ideal solar cell. Mathematically, we can write field factor is equal to Vm into Im divided by VOC into ISC, where Vm is the maximum voltage at maximum power point Pm. Im is the maximum current at maximum power point Pm. The efficiency of a solar cell is defined as the ratio of energy output from the solar cell to input energy from the sun. Mathematically, we can define the efficiency eta is equal to Vm into Im divided by Pin, where Vm and Im are the maximum current and voltages as mentioned earlier. Pin is the energy input from the sun. The importance of calculating efficiency of a solar cell to compare the performance of one solar cell to another. The efficiency of a solar cell depends on the solar spectrum, intensity of sunlight, and the cell temperatures when exposed. Solar PV system is playing a vital role in power generation system in all over the globe. To improve power generation through solar PV technology, it is important to research development and challenges relating to environmental effects on solar cells. And in India, many villages can electrified by proper implementation of government projects using solar PV system. These are the references from where I have prepared the video. Thank you very much for watching my video.